Hey everyone, so this video we're going to talk about logarithmic differentiation, which is an item which is an extremely helpful tool to help you working with complex derivatives, although it's not really an official tested item on the AP exam. So the one question that I left you with in class here today was this problem here. So x minus 2 quantity squared over the square root of x squared plus 1. And the question I left you with is how could we find this derivative without using the chain rule slash quotient rule in order to complete this? And so this concept of logarithmic differentiation is the idea that we know logarithms when inside of logarithms, inside of the power, if you have any exponents, any products, or any quotients that you can split them up using properties of logs. So we're going to use that to our advantage because what I'm going to do is I'm going to take the natural log of both sides of this term, of this equation, which gives me the natural log of y equals the natural log of, and now I have this x minus 2 quantity squared term. I'm going to go ahead and write this as x squared plus 1 to the 1/2. So what this allows me to do is we can now take its derivative implicitly. But to do that first, I'm going to go ahead and take care of the fact that there is a quotient in here. So that's going to give me natural log of x minus 2 squared minus natural log of x squared plus 1 to the 1/2. And then lastly, before I take this derivative, we're going to go ahead and move those exponents out in front. So this becomes 2 ln of x minus 2 minus 1/2 ln of x squared plus 1. So what I've done essentially now is I've taken this rather complex problem and I have turned it into a much simpler derivative that I can take. Now keep in mind this has to be done implicitly. So for example, when I go ahead and I take the derivative of this left term, this is going to become now 1 over y dy dx. But now the rest of this is going to be much simpler. So it's going to be 2 over x minus 2 minus 1 over, and again, this 2, that's where that is. That's where it's coming from. X squared plus 1 times 2x. So I'm going to actually go ahead and just put that 2x up top. And we'll say the 2x is here. Now, I'm not fully 100% done yet because I do need to get that dy dx by itself, which means I'm going to multiply both sides by y. So I'm going to get y times, and then in parentheses, 2 over x minus 2 minus 2x over 2 parentheses x squared plus 1. Now, we don't want to leave this answer derived implicitly because we actually do know what y is equal to. That's from the original problem. So I'm actually going to go ahead and we're going to erase that y. And in its place, I'm going to go ahead and replace it with the original function, which is x minus 2 squared over the square root of x squared minus, or x squared plus 1. Now, this obviously could be distributed, and we could do some additional simplifications to try to make this a single term. But overall, we have our derivative. We have it in terms of x. There's no complex fractions or negative exponents. So I feel pretty confident with this as a final answer. So I'm going to give you one to try now. Based on this example, I'm going to have you try another one here. I'll have you pause the video to try it out, and then we will go back over it together. So the equation here is going to be y equals e raised to the 5x squared times the square root of 3x plus 7. Pause this video to go ahead and take a moment to complete that. So as the last example showed, we're going to go ahead and take the natural log of both sides. So the simplification, this will be natural log of. Now this is going to get split because of the multiplication sign. This is going to become natural log of e to the 5x squared plus natural log of 3x plus 7 raised to the 1/2. Now there's two things we can do to simplify this. So the first one has to do with the natural log of e. So the natural log of e is actually their inverses of each other. And so this entire term is just going to become 5x squared. And the reason why is 5x squared is an exponent. So we're going to go ahead and move that in front, making this natural log of e. And we know that the natural log of e is just going to be 1. So this becomes 5x squared. That's first term. The next term is going to become 1/2 natural log of 3x plus 7. Okay, so from here we're ready to take the derivative now. So this is going to become 1 over y dy dx This is now going to become 10x plus 1/2. This is going to be 1 over 3x plus 7 times the derivative of the inside, which is 3. And so I'm going to keep that 1 over y here for one more step, just because I want to organize this a little bit. So 10x plus, this now becomes what? 3 over 2 parentheses 3x plus 7. We're going to multiply both sides by y. And just like the last question, you're always going to be left with having to rewrite the original term there first. But that's a 10x. 3 over 2 parentheses. Actually, I'm going to distribute that. That's easy enough to distribute. So that's going to be 6x plus 14. The original term, of course, was e raised to the 5x squared. And then square root of 3x plus 7. Square root of 3x plus 7. And there we have, again, in lies our final answer here, our derivative. One last example I'm going to show you for this video has to do with a function that we don't know exactly what to do with unless we maybe use some logarithmic differentiation. What if I had y equals x to the x? It's a really unique prospect here, because what rule do we use here? Do I use the rule for exponential because there's a variable in the exponent? So is this an exponential function? Or because there's an x here, is this a polynomial function, which would tell me to use the power rule? So the confusion is we have two different rules. We have rules for exponential functions for derivatives, and we have rules for polynomials. And the answer is neither. Okay, it's neither. And the best way that we're going to be able to do this is we're going to have to, again, use logarithmic differentiation in order to help us solve this. So we're going to have the natural log of y equals to the natural log of x over x. So this becomes natural log of y times x times ln of x. So this now allows me to be able to go ahead and take the derivative. So let's do that. This is actually going to be a product rule. So x times, so left derivative of right, plus right derivative of left. I'll keep simplifying this just a little further. So this is going to become 1 plus natural log of x. We're going to multiply both sides by y. Remember that y is x to the x. So we're going to get, looks like this as our final answer here. So this is going to be our final answer to the question. So that concludes logarithmic differentiation. So once again, as I summarize the video here, it is not a required strategy for the AP exam. You ultimately could do the first two questions, at least on this video, without the use of logarithmic differentiation. You would just have to make sure that you write out your product, quotient, and or chain rule appropriately and then simplify where needed. But this certainly can take really complex derivatives and make them a lot simpler. Thanks for watching.